All right, let's dive in. We're going to talk about something every drilling engineer deals with every single day. Data. You know data is king out on the rig. But have you ever stopped to think about how that crucial information gets from the drill bit all the way to your screen? It's a pretty amazing story, going from what was basically on-site chatter to a full-blown, real-time global conversation. So let's get into it.
So picture your typical setup on any rig, right? You've got your MWD tools spitting out directional data, you've got your EDRs logging every single parameter you can think of, and then there's the mud logging unit, analyzing cuttings. I mean, they're all from different companies, all doing their own thing. So how in the world do they all talk to each other? How do they speak the same language without it just becoming, well, a total mess? That's the big question, and it's exactly what we're going to break down.
Okay, here's our game plan. We'll start with the big data challenge drillers faced. Then we'll get into WITS. Think of it as the rig's first intercom system. We'll even decode a WITS packet to see what it looks like. After that, we're taking the huge leap to WITSML, looking at the power of remote data. And finally, we'll peek into what's coming next in real-time operations.
First up, drilling's data challenge. Let's rewind a bit, because before we had any kind of standard, the world of rig data was pretty much the Wild West. Everybody had their own proprietary formats. Just try to imagine this for a second. Every single time an operator brought on a new service company, a team of engineers had to sit down and write brand new, custom software just to get the two systems to talk to each other. It was, a nightmare. So inefficient. It meant frustrating delays, super expensive debugging on the clock, and the absolute worst part, you were losing valuable data in translation. This wasn't just an inconvenience, it was a massive bottleneck holding the whole industry back. So how do you solve a problem like that? Well, the industry came together and created the first standard, the Well Site Information Transfer Specification, or WITS. You can think of it as the rig's intercom. It was the very first real shot at creating a universal language everyone on the rig could understand.
So what exactly is WITS? Well, the key thing to remember is that it's a super simple but really effective communication format. It's basically a stream of text, what we call fixed format ASCII, sent over an old-school physical serial cable. And that intercom analogy, it's perfect. It's a closed circuit, just for the rig. It's not hooked up to the internet or anything. Its one job, and it does it well, is to let all the essential gear on the well site talk to each other, directly and reliably. Let's walk through a classic example. So your MWD tool is way downhole, right? It's gathering all that critical telemetric and formation data. It shoots that info up to the MWD surface system. But here's the problem. How does the drillers see that MWD data alongside all the rig's own parameters? Well, that's exactly where WITS comes in. It's the data link, the bridge. It pipes the MWD data right over to the EDR system. And boom, the rig crew can see everything, all integrated on one screen so they can make those critical, in-the-moment steering and drilling decisions.
Okay, so we know WITS is the glue that connects these systems, but what does that data actually look like when it's flying down the wire? Let's roll up our sleeves and actually decode a WITS packet.
For all its importance, a WITS packet is shockingly simple. It's just a series of characters. Every single packet starts with a double ampersand, and it always ends with a double exclamation point. Ew. Everything sandwiched in the middle, that's your data. And it follows a simple pattern, a record number, an item number, and then the actual value. That's it.
So how do you make sense of those numbers? Well, it's basically like a secret decoder ring. The WITS standard defines what every number means. So, for example, if you see a record ID of 01, you know you're looking at general time-based data. And inside that record, item ID 13 always means rate of penetration. Item 14, that's your hook load. 21, standpipe pressure. So when the EDR gets a little string of text like 013160, it knows instantly, okay, that's ROP, and the value is 60. Simple, right? But incredibly effective.
Now, WITS was fantastic for on-site communication, but it had one pretty major drawback. And as the world got more and more connected, this limitation became a huge problem. This brings us to the leap to WITSML, connecting the rig to the rest of the world.
And here it is, the critical limitation of WITS. You had to be physically at the rig to get the data. That's the whole story. Because it was designed as a local intercom using physical cables, there was no simple way to get that live data stream to, say, an office on shore, or to an expert sitting halfway across the globe. And in an industry that was demanding faster, more collaborative decisions, being stuck in a local-only world, well, it just wasn't going to cut it anymore.
And that's where WITSML comes in. It's the successor to WITS, and the ML is the key part. It stands for markup language. WITSML uses XML, which is a standard language of the web. So instead of simple text characters over a serial cable, we're now talking about web services running over a standard TCP/IP internet connection. Let's go back to our analogy. If WITS was the rig's intercom, then WITSML is the rig's high-speed fiber optic connection to the entire world.
This table really lays it all out, doesn't it? I mean, look at the difference. WITS, that's old-school ASCII over a serial cable, and it's strictly local. WITSML, that's modern, structured XML over the web, giving you global access. But here's maybe the biggest game changer of all: data history. With WITS, you just got a live stream. If you missed it, it was gone. With WITSML, you can actually query historical data. You can go back and pull data from yesterday, last week, or any point in the well's entire history. That is a massive leap forward.
So, the rig is officially on the internet. Big deal, right? Well, yeah, it's a huge deal. Let's talk about why this remote data capability matters so much. What does this actually let us do that we could never do before?
Oh, the benefits are just enormous. Suddenly your decision-making gets way better because the best experts can see the data no matter where they are. You can have your top geosteering guru guiding a well from an office 1,000 miles away. It lets your teams be proactive, spotting a dangerous trend and stopping it before it becomes a real problem, instead of just reacting after the fact. The collaboration between onshore and offshore teams goes through the roof. And like we said, that historical data is pure gold for data mining, planning future wells, and doing deep dive analysis after something happens.
And this is what it looks like in practice. This picture says it all. WITSML is the engine that powers these real-time monitoring centers. You've got data flowing seamlessly from that offshore platform right into a room packed with onshore experts. They're looking at the exact same screens as the driller, analyzing the exact same data, and they can collaborate with the rig crew like they're standing right next to them. It just completely demolishes the barrier of distance.
Okay, so we've come a long way, right? From these totally isolated systems on a single rig to a globally connected network. So the big question is, what's next? Where is all this heading?
So let's just recap the journey real quick. We started with WITS, that essential on-rig intercom that for the first time taught all our machines how to speak a common language. Then we made the massive jump to WITSML, a powerful web standard that didn't just connect tools on the rig, it connected the entire well site to a worldwide network of experts.
And that brings us to the big final question, the one I want to leave you with. WITSML connected the rig to the office. It connected people to the data. So, what happens when it connects the rig directly to AI-driven automation? What does our world look like when intelligent systems are analyzing that WITSML data and making or suggesting decisions in milliseconds?